Hi everybody, welcome back. It's Nora and I am doing a kind of convoluted picture-in-picture thing here with photo booth down in the corner because I do think it's important to see, my face and make it a little more personal. So here I am. All right, in this video, this is lesson 23. The students will be required to graph a random equation that is in standard form. Okay, so let me show you around here. So I'm going to click preview, and this equation is generated randomly. So look at that one. We're going to do it again, and it will be a new one. New one. All right, so what the students would be required to do is, well, this part's up to you to enforce if you want them to do that, is are they going to show their work here on how they solve for slope-intercept form? Because that would need to be checked by you, that there's no feedback for that. And then when they go to graph, let's see here, what would this be? 4 2/3? Can I do this in my head? Nope. 3/2? Nope. What am I doing? 4 and then 2/3, right? Well, this is embarrassing. Negative 2/3. Yes, I teach math. Anyway, you can see now that when it's wrong, the teacher gets the feedback that the graph is wrong, and the students do as well. And as soon as it's correct, they both get that feedback. Okay, now all of this is optional. If you don't want the students to get this feedback, don't give them that part. So what I did was create a little lesson here where they get, I think, 3 problems that are randomly generated. And then on the 4th screen, we have this infinite practice. So the way I handle it is I require the students to do the other screens, and then I always add on the screen for infinite practice, because there's always some student who is like, oh, I want to keep practicing. That was us in school. So there's more of us out there. So how is this created? Well, let's get started. I'm going to open up a new screen here, and I need the graph component. I need 2 note components, one to give them the feedback and one to give them, directions and the equation. And then I also want the sketch component so that they can show their work. Now, if you don't want them to show their work there, if you have them show their work on paper, that's up to you. You don't have to put that one in. All right, so I'm looking at my notes here. Oh, and then at the end, I'll show you how to add the button for the infinite practice. Okay, I'm going to start with the graph component, and I'm going to label this one graph 5 because I'm on the 5th screen. Again, that's just how I do my labeling. All right. Now there's 2 places you go. You can click on the grid, and that will take you into edit the graph. And then there's the separate place up here for the computation layer. So I'm going to edit the graph. And what I want the students to do is I want them to have 2 movable points that they're going to use to create the line I want. So I'm going to call those ordered pairs A, B, and we'll press return to get those sliders, and CD. And again, return to get those sliders. Now, again, like in my other videos, we're going to change the step to 1, because if we don't, it's just too hard for students to, and anybody, to get it like right on the integer point that you want. Okay, now I do want this to calculate the slope that's between these 2 points. So as they're moving it, I want the slope to recalculate. So we're going to put in m equals, and this is still y2 minus y1 over x2 minus x1. So d minus b over c minus a. Now if you take these points and you move them around, you can see down here that the slope is recalculating. Okay, and it will do that throughout the activity. I also want it to calculate the y-intercept. So I'm going to call that z, because b was already taken. There's b, so I can't use that again. So this is before Christ minus after death over c minus a. Sorry. So this will calculate the y-intercept that is happening, you know, with the line that passes through these 2 points. So as we move these again, both of those will recalculate. Now I do want the students to see a line actually going through those 2 points. That's y equals mx plus z. There we go. Now, at this point, you want to drag these points to where you want the students to see it when this opens up. And I think a horizontal line is a nice place to start. That way you don't accidentally give them the line and poof, it's right as soon as they open up the screen. So that's what I do. And I don't have slope of 0 in this. Okay, so this is all we're going to do in this part of the graph component for now. We'll come back to this later. Okay, so I have all my notes here. Are you scared? Look at all that. All right. The next thing we're going to do is go into the note component, or actually label the note component where all of this is going to happen. So I'm going to call this note. It's screen 5, and it's my second note, so I'm going to call it B, note 5B. And I'm going to go into the computation layer here. All right, this is where all the guts of our activity are. Guts are, yes. So I labeled it. So we need random numbers. R equals random generator, empty parentheses for now, right? Are you getting better with this? Oops. Okay, now at this point, I'm going to make a little note here. Now the form of my equation is going to be EX plus FY equals G. So equation format is EX plus FY equals G. Okay, that's what it's going to look like. Now E and F, make another note here, E and F are random integers from 2 to 6, and they're either positive or negative. Okay, so I'm going to have to figure that out. So let's do that right here in this spot. So the sign of E, it's either going to be positive or negative. It can go one of 2 ways, positive or negative. So E sign is going to be some random integer. Wow, look at all those ends. From 1 to 2. Yeah? Yes. Okay. Now E will equal 2 things. When the sign, so when E sign equals 1, then I wanted to pick a random integer from 2 to 6. Okay? Otherwise, that means that E sign is 2, and I wanted to pick a random integer from -6 to -2. So I am skipping over -1, 0, and 1. I'm going to do the same thing for F. So I'm just going to copy all of this. I'm going to paste it right here, and everywhere there's an E, I'm going to change it to an F. Done. So that saved me a lot of time. All right. So E and F, there's some random integer from -6 to +6, not including -1, 0, and 1. Okay, let's move on to the next part. Now for G, I want that to be some kind of multiple of F, because when they're solving for Y, when they get it in slope-intercept form, I want the Y-intercept to be an integer. I don't want it to be some funky decimal. So let's make a note of that. I want G to be a multiple of F so that the Y-intercept is an integer. Okay, note to self. I'm just going to call it mult for multiplier. And I want it to be a random integer. I picked 1 to 7. You do what you want to do there. You could really go from up to 10, right? Because our grid shows the window goes to 10. I think 7's good. Then my numbers don't get outrageous. Okay. Then G will equal the numeric value of, so in those parentheses, let's open and close quotation marks right away and then get between those. What we're going to do is take that multiplier times f, and that's what g will equal. So I'm going to take this multiplier, that's that weird notation, right? The $, curly brackets, what your variable is, close the curly brackets, times weird notation, f. Okay, so I have all that. Now I want to start building the equation. The problem with the equation is, so looking up here at my format of it, if f is positive, it's not automatically going to put the plus sign. So I need to distinguish between those. So here I'm going to write the equation, sure, I like that. We'll need to show the plus sign if f is positive, or nothing if f is negative, because the negative will count as the minus sign. So the equation will need to show the plus sign if f is positive, or nothing if f is negative. Okay, so I'm getting better at putting these notes in so that you can see what's going on here. All right, so I'm just going to call it equation. And that will equal, so we have two options. When f is positive, this will happen. Otherwise, f is negative, and this will happen. So when f sign equals 1, so I'm looking up here, when f sign equals 1, we're going to have a positive number. So this is where I'll need the plus sign. All right, I'm going to do, are you getting used to my sign language yet? The, not the quotation mark, but the one next to the number 1 on your keyboard. It's above tab and to the left of 1. That's that one. I'm going to open and close that right away. What that does is it's going to put this text in the math format, the math font, okay? So I'm between those two symbols, and I'm going to type this out. I like to double check myself. It's right here, ex plus fy equals g. So, weird notation, ex, this will need the plus sign, plus weird notation f, y equals weird notation g. Okay. Otherwise, and I'm going to copy this that we just typed, put it here. Otherwise, it's negative, and I don't need the plus sign. So all I did was delete that. Okay, so there's my equation. Now I want this to show up, right? It's here in the background, but I need it to show up in the note. So the content of this note, I'm going to put some directions first. I want the students to click and drag the points in the graph, the points to create the graph of the equation. And now I want the equation to show up. I want it to show up on the next line, so I'm going to press return, and then I'm going to do weird notation, equation, close it, close my quotation marks, and that's what's going to appear in my note. Let's see what we have so far. So I'm going to close that and click on preview. Click and drag the points to create the graph of the equation, and you can see that we have no feedback here and we have no feedback here. So we wouldn't know if the kids were right or wrong at this point. And if you wanted to stop there and grade everything by hand, you could. Why would you do that? All right, let's let the teacher know if the students are, oh, no, let's keep going here. We have work to do. Who am I kidding? Okay, now, oh, I have to calculate. We want to calculate the slope and y-intercept of, I apologize, my keyboard sticks. So anytime I go to type, I'm always deleting what I just typed because I get all this garbage of the random equation. Okay, so we have to do that. Let's figure out the slope. I'm just going to call it slope. And to figure that out, that is where it's e divided by f times -1. Okay, so we need the numeric value of what I just said there. Quotation marks, and I'll work inside there. So I'm going to start with -1 times e, so weird notation, e, that's not e, divided by weird notation f. And there we go, that's our slope. Or at least that's what the correct slope should be. The y-intercept, now this is really cool because that will equal that multiplier that we have. So it's just y-intercept equals the multiplier. Okay, so now what we do is, in this part, we have what the correct slope and y-intercept is. In the graph component, it's calculating the slope and y-intercept that the students are doing, and now I want to see that they match. So if they match, then the student is correct. So I need to pull in that slope and y-intercept from the graph. Get slope and y-intercept from the graph. All right, so I'm going to call this G slope will be, we called that graph 5 dot number, and we called it M. Okay, so from graph 5, grab the number M, and we're going to call it G slope for graph slope. All right, the graph y-intercept, so gy int equals, so from graph 5, grab the number z. Z was our y-intercept. All right, now after we do that, we want to check that they match. Check that slopes and y-intercepts match. And I'm going to call this the check. So check will equal if the slope equals the g-slope and the y-intercept equals the gy-intercept. Then they're right. Okay, so this is everything that should be in the note component. Everything else has very minimal coding to it. So again, if we preview, it looks like nothing has changed, but actually quite a bit has, right? All right, let's let the teacher know if the student is correct. And we have to do that in the graph component because that's where the students are doing things. So that's where the that has to go. So in the graph computation layer, flip my page of notes. We're going to call this check again. But it doesn't recognize this from the other component, from the note component. So we have to pull that in. All right, to do that, which component is it? Well, we called it note 5b dot script pops up, and we want that check. All right, and I just renamed it the same thing so I don't get confused because, you know, you see these? They make me forget things. All right, correct would be when check happens. Done. Okay, ooh, look at, messed up my hair. Now, if I preview this, you're not gonna see anything. You'll just see a dot because it noticed that the students are doing something in the graph component, but they're like, yeah, but wait, you have a sketch component you need to check. So no, and so this is up to you if you want to do this or not, but I'm going into the sketch component here, the computation layer, read only true. Now I know that students have to do work in here, okay? So I need to check that they did something before I would just give them credit for this, you know, because it's too easy on the photo math to just be like, click, here's the answer, I think. All right, so now if I try it, you can see that we get some feedback here as a teacher. All right, let's give the students some feedback. So I'm going to do that in this first note here. Again, I have to pull in that check variable, and that was in note 5b. dot script dot check. Lunch is over. Then what we're gonna do is, this will be like what I want to display. So when they are correct, so when check does happen, we'll give them some feedback. Otherwise, they're wrong and they'll get this feedback. And my standard feedback here is emojis. So I go with the green check mark if they're right, and I go with the red X if they're wrong. And you could put words, you could put emojis. Again, at least on the Mac, Control, Command, and Spacebar, all at the 3 times, brings up your emoji menu. Okay, so here's what I want it to look like. This is my normal thing. You might have your own thing that you do. Correct, and then I have it give the display. And then close your quotation marks. Okay, so now the students preview. They will also get some feedback here, like, oh no, I'm still wrong. I'll see if I can do this one. Let's see, so 4, that should be +1, right? There we go. Okay, now again, what I like to do, if you want to pretend these first 4 aren't here, I like to take this and copy it. So I'm just gonna do Command-C, Command-V, click on this, Command-V, click on this one, Command-V. You can do this as long as you want. So depending on how many problems you want your students to do that. And then on the last one, add an extra one. Now I'm going to add a button for those students who are like, I want more. I always make this optional. I said, I'm not looking at it. I won't even know how many you do. You could do 1,000,000 and it won't tell me. So I need to add a button. There it is. And I'm going to call it button 8 because I am on screen 8. And I'm going to move it up here. I'm going to put it between the feedback and the actual problem. And instead of try it, I want it to say, get another system. How about a smiley face? All right. Then, in your note component here, it's still called 5B. In the very first line, in these parentheses, we're going to put the name of the button. So it's button 8 dot press count. And that's it. So now, did I put system? Sorry, that's what we were talking about earlier today. Get another equation. That's what we want. Now if I preview it, get another equation, they get another random equation. And every time they do this, 7 6/5, it'll mark it right. Then if I press the button, it's a new one, so it will be wrong until they get it correct. So there you go. That's a whole lot of stuff happening. Again, all of the parts are optional. If you're given a test and you don't want the students to know if they're right, delete this component. Just gone. Your programming will still work there. If you don't have them do their work here, delete it. You don't need that. All right. Guys, I hope you find this helpful. See you next time.